So now that we've talked about circles, we're going to talk about ellipses. So an ellipse is just one of them. Ellipses would be more than one. So what we're going to do first is we're going to draw a picture of it, and then I'm going to give you like the super mathy definition that a lot of people are going to be like, oh, what does that mean? And then we'll actually work with the picture and it will make more sense. Okay? So on your paper, go ahead and make your sketch kind of big so that you can fill it out and like label things. But here's one example of an ellipse. Oop.
It's like a movie.
Yeah, it's like an oval. Like a circle that has been squished. So just like with the circle, we're going to find the center. That's going to help us figure out how to graph it. And then from the center, instead of having a radius, or instead of having points that come from a radius, we have a vertex. So if you look from the center, the points on the edge of the circle, or not the circle, but the edge of the ellipse that are furthest from the center are called vertices if you're talking about plural, or vertex if you're just talking about one of them. So vertex, vertex, but together those would be vertices. The points that are straight out from the center but are shorter or closer to the center are called the Co Vertices or a Co Vertex. The line that cuts the ellipse in half and goes through the vertices is called the major axis. So axis like an axis of symmetry, or the line that cuts it in half. The line that connects the two co-vertices together is the minor axis. And then there's one more set of points. They are on the major axis, and they are not halfway between the center and the vertex. A lot of people think they're halfway. They are not. They are closer to the vertex than they are to the center. And these points, if you're talking about one of them, it's called a focus. If you're talking about two, some people pronounce it foci for plural, but it's really foci, F-O-C-I, which is weird. So it's a focus if you're talking about one of them. It's foci if you're talking about both of them. Okay. So if the ellipse is oriented this way, that's what all the terms are. You can also turn it on its side. So then this time you still have the center. This time the vertices would be on the side, and the co-vertices would be on the top and bottom. So we still have the major axis connects the vertices, so that means that this time the major axis happens to be horizontal. Last time it was vertical. And the minor axis still connects the co-vertices. And each focus still shows up on the major axis, and it's still a little bit closer to the vertex than it is to the center. So this is a focus, and this is a focus. And together we call them foci or foci, depending on maybe what region you're in. I'd say I hear a lot of high school teachers say foci, and I hear a lot of college professors say foci. And I don't know if both of those are right or one of those are right or what. People like foci so they can say, what the foci? You know, because they're looking for it.
I'm going to say focuses.
You going to say that?
Yeah.
That will make you sound really intelligent, so that's a good idea. All right, so do you guys remember when we were, you were taking the notes on the circle, and I said that the actual definition of a circle was it's the set of all points in a plane such that each point is equidistant from another point called the center. But we all know what circles are because we've dealt with them for so long. We have a definition that's very mathy, kind of like that for ellipse as well. So we're going to go ahead and write that definition down, and then I'm going to describe to you what it really means because it's kind of confusing. So an ellipse is the collection of all points in a plane such that an ellipse is the collection of all points in a plane such that the sum of the distance of any point to each focus is constant. So an ellipse is the collection of all points in a plane such that the sum of the distance of any point to each focus is constant. What does the word sum mean in math? Sum, what does that mean? Add, it means add. Okay, so if you have, if you're using a pencil, grab a pen, so you can do this next part, or if you're using a pen, borrow somebody's pencil. What they're talking about here is, and it doesn't matter which of these sketches you draw it on, take your pen or your other color and draw a point anywhere on the curve. It doesn't matter where. So if this is your pen mark, you're going to draw a line from one focus to that mark, and you're going to draw a line from the other focus to that mark. So they're saying if you take each of those distances and you add them together, you'll get a number. So maybe that number is 75. Then if you pick another point on the same ellipse and you draw a line, this time I'll do it dotted, and then draw another line from the other focus, then those two numbers would also add up to 75. That's what that says. No matter what point I choose on the curve, the distance from the point to one focus plus the distance from that point to the other focus, it would always equal the same thing. Yeah, it's kind of funky. I'll see if I can get an animated visual of like how that works. But that's what they're talking about in the definition. Is instead of saying the distance from the center is equally distant on all the points, now they're saying the sum of these two distances is always the same as you move your way around. Okay? So, if that definition does not work for you, you can think of an ellipse as a squished circle, if that makes more sense. Okay? This definition of an ellipse will not hurt you in pre-calc. So if you do not understand this definition, you will be fine. You'll be able to survive everything. All the math we're going to do, you can do without understanding this definition. Yep. Yes?
Can I sharpen it?
Yep. Yep.
Okay.
But not in that one. Don't do it in that one. You're going to break my sharpener. Colored pencils are really hard on pencil sharpeners. So if you're going to do a colored pencil, grab either do the crappy one or do a handheld sharpener. Yeah, that's why I wrote it on there.
She just said
The other one's fine. Yeah. All right. So on your notes, we're going to write down the equation of a circle and we're going to compare it to an ellipse so you guys can see the similarities between the two. So the equation of a circle says x minus h squared plus y minus k squared equals r squared. And then what we're going to do with this equation of a circle is we're going to divide this by r squared, and we're going to divide that by r squared, and we're going to divide that by r squared. So that means that the equation of a circle is x minus h squared over r squared plus y minus k squared over r squared equals 1. That's an alternate form for the equation of a circle. This form right here is called the standard form of a circle. Standard form of a circle would be like the original form. This one, I'll move my hand in a second. This is the standard form for a circle. This is an alternate version of the standard form for a circle. Okay? The standard form for an ellipse is x minus h squared over a squared plus y minus k squared over b squared equals 1. So when you're looking at the equation of a circle and an ellipse, the only difference is that a circle would have the same number underneath, because that number underneath represents the radius of the circle. An ellipse would have two different numbers underneath, because it's kind of like you have one radius going left and right and another radius going up and down. Right? So that is the only difference in the equations for a circle versus an ellipse. All right? Does that make sense when you're looking at it? You see what I'm talking about? Okay. So when we look at this, we're going to say, no matter what, if you're talking about a circle or an ellipse, the center is always HK. So the opposite of what is in the first set of parentheses, the opposite of what's in the second parentheses. The A value, notice they give you an A squared. So we're not going to look at A squared, we're going to look at just the A value. You can think of that as the radius to the left and right. Calling it a radius is not accurate, but that's essentially what it is. And then the B value is like the radius up and down. So if the radius to the left and right is bigger, then you're going to get one of the pictures that looks really wide. If the radius up and down is bigger, then you're going to get the picture that looks really tall. Okay? So this would be a version where the radius up and down is bigger. This is a version where the radius left and right is bigger. All right? Does that make sense so far? Okay. So we're going to be studying ellipses for today. We're going to start with the simple stuff today. Tomorrow we're going to get into the more complicated pre-calc stuff with it. So for today I'm just going to show you guys an example of an equation and then how to find the different things that we labeled in our notes. Okay, how to find all those different like ellipse vocabulary terms. So we're going to say, for example, let's say we're going to sketch the ellipse x minus 2 squared over 16 plus y plus 1 squared over 9, and that equals 1. So if that's our ellipse, what's the center? Positive 2, negative 1. Yeah, 2, negative 1. So 2, negative 1. And if 16 is like the radius to the left and right squared, then how far to the left and right do we actually go? 4. So we're going to go 1, 2, 3, 4. and 1, 2, 3, 4. So that's further, right? 4 is going to be further than what we're going to graph for this one, because this one's 16 and that one's 9. So since the 16 is bigger, that means what we just graphed were the vertices. Okay? So I'm going to say vertices. We had the point 2, negative 1, and we went to the left 4, which gave us the point negative 2, negative 1. And you can get that by looking at the picture, or you can get it by taking your x coordinate and subtracting 4, since you went to the left. So that's negative 2, negative 1. And we went to the right 4, we had 2, negative 1, move it to the right 4 gives us 6, negative 1. So again, you can get that either from the picture, or you could take your x coordinate and add 4 to it. So your other vertex is 6, negative 1. So you know the vertices and the co vertices based on how big the numbers are. So the vertices are going to come from this number because it's bigger than 9. So left and right 4. The co vertices are up and down 3. So right now we're finding the vertices. The co vertices are going to be from that center 2, negative 1, and we're going to go up 1, 2, 3. That's because this is 9, so the square root of 9 is 3. So we go up 3, and we go down 1, 2, 3. So if we have the point 2, negative 1, and we went up 3, then that's 2, 2. From the point 2, negative 1, if we went down 3, that's 2, negative 4. And again, you can get that by looking at the picture, or you can get that by taking the y coordinate and adding 3 to it and subtracting 3 from it. So if we look at our ellipse, it looks like that. And just like we talked about, oh, that's terrible. Okay. They're hard, yeah, you'll get better at it. And just like we said, we talked about in the video with the circle, the center is technically not a point on the graph. We draw it for reference, but it's not actually a point that would make the equation true. Okay, so we have the center, we have the vertices, we have the co-vertices. We are not going to worry about finding the focus today. We're going to worry about that tomorrow. But we can find the major axis and the minor axis. So both the major axis and the minor axis, they both go through the center. So the points that we get the center from, those are going to be important for us in finding each axis. But the major axis goes through the vertices. It goes the long way. And so our major axis is a horizontal line. How do we write the equation of a horizontal line? Y equals. So y equals, if we look at our center, it's going to be y equals negative 1. And if you look at the picture, that confirms it, that the horizontal line went down 1. So y equals negative 1. The minor axis goes through the x value of the center, and it's a vertical line, so that's x equals 2. And you can see that that vertical line is 2 to the right of the y-axis. Okay, so those are the things we're going to be focused on finding today. How do you guys feel about finding all those different things?
I don't feel good about drawing in freehand because it looks too.
Yeah, they'll be a little bit easier to draw when you actually have graph paper.
This rise?
Yeah.
On the vertices and co-vertices, I don't know what you did.
So the 16 is where I got the vertices from because that number's bigger. And since it's underneath the x, that tells me that it happens to the x values. So I took my center and I went left 4 and right 4. So 2 minus 4 is negative 2. 2 plus 4 is 6.
So it has nothing to do with x minus 2?
It has not, well, you kind of, because the center was positive 2. So positive 2 minus 4, positive 2 plus 4. You can also do it visually. So if you look here and say that it's kind of like the radius squared is 16, so the radius is 4. You could take your center, go to the right 4, take your center, go to the left 4, and just see what those points are. And then for the other one, the co-vertices, I only went up 3 and down 3. So my picture, up 3, down 3, those are my co-vertices. Okay. All right, let's do another example like that. So for this one, we're going to sketch x minus 5 squared over 9 plus y squared over 20 equals 1. Okay, so what is the center? Okay, so the center is 5, 0. And if the number underneath x is 9, how far to the left and right are we going to go? 3. Now the number underneath y is not nice this time. It's 20, so it's not a perfect square, which means we have to think about decimals. We're going to go up a decimal amount, we're going to go down a decimal amount. So the square root of 20, it's between 16 and 25, so that means it's before 4, it's between 4 and 5. Can somebody check and see what the actual number is?
It's 4.47.
4.47, so we're going to go up and down about 4.5. Okay. All right, so do you guys want to sketch the part where we go left and right 3, or the part where we go up and down 4.5? 3? Okay, so we'll go left, 1, 2, 3. We'll go right, 1, 2, 3. Did we just draw the vertices or the co vertices? The co vertices, because that's a smaller amount. Okay. So I can go ahead and write my co vertices. So I took the point 5, 0, and I went to the left 3, and I went to the right 3. So what are my 2 points?
2, 0.
Yep. Okay. And then we have to do the points, the vertices, where we go up and down. And we said that the square root of 20 is 4.47, so about 4.5. So I'm going to go up 1, 2, 3, 4, and a little bit more. Up 4.5-ish. Down 1, 2, 3, 4. 4.5-ish. Now, for the vertices, anytime you have a square root number where you would have had to take the decimal, we're going to use the exact answer when we write our points. So I'm going to say that this point, the x-coordinate of 5 stays, so you'll notice that has an x-coordinate of 5, and so does this one. And then I'm going to use my y-coordinate. I'm going to say 0 plus square root 20, and I'm going to say 0 minus square root 20. And I know that we can simplify 0 plus square root 20 and just call that root 20. But typically, your center doesn't have 0 as one of the values. And if you had a number other than 0, then you would have just left that number there. So do not write the decimal. You're going to have it as a number plus a root anytime you have a root answer. Okay? So 0 plus root 20, 0 minus root 20 is totally fine to write it like that. Better than rounding because that's exact. Okay? All right. We also want to find the major and the minor axis. So which one is vertical? The major. So here's the major axis. It's vertical, so that's an x equals equation. And if we look at the center, that tells us that the major axis is x equals 5. And then the minor axis is going to be this one, which is y equals 0. Are you all done? Okay. How are we feeling about the pictures now? Relatively okay? Now today, remember, today's not the only day we're going to go over it. Today's just getting started. Just kind of an intro to understand what the words mean and all that stuff. Okay. All right, one last example. So we're going to take an equation that is in general conic form. And we're going to put it in the standard conic form so that we can see what the center is, and so that we could graph it and find the vertices and co-vertices and all that if we wanted to. So we have 4x squared plus y squared minus 8x plus 4y plus 4 equals 0. So just like with circles, our very first step is going to be to write the x's and put those all together, and take the y's and put those all together, and then take any number that doesn't have a letter with it and move it to the other side. So I'm going to say that I've got 4x squared minus 8x, and I've got y squared plus 4y, and overall that equals negative 4. Thank you. Do you guys remember what we do from the completing the square video if we have a number in front of the x squared? You factor it out. So we're not taking out the whole GCF. We're just taking out the number. Yeah. So I'm going to take out the 4. And if I take out the 4, that leaves me with x squared minus 2x. Okay? The y's were already ready to go. We don't have to worry about those. It still equals negative 4. Okay. So now we're at the point where we can divide by 2. So we've got negative 2 divided by 2 is negative 1. Negative 1 squared is positive 1. So the number that completes the square is going to be a plus 1. But we didn't really plus 1. We really did a 4 times a positive 1. What's 4 times 1? 4. So we really added 4 to the left side of the equation. So what should we add to the right side of the equation? So we're going to do plus 4 over here. Alright, so the reason we said it was a plus 1 inside of the parentheses, but we really had 4 sets of that plus 1. So it's really 4. Okay. What do we do with the 4y? Divide by 2. So 4 divided by 2 is 2. And then we do 2 squared is 4. So here there was nothing in front of parentheses, so we're good. We don't have to worry about that. We added 4 to the left side of the equation, so we add 4 to the right side of the equation. So now we're going to think of this as something squared plus something squared equals something. And we know that in front of this something squared, we do have that 4 that we took out. So this is going to slide right down here. Okay. So what goes in these parentheses? Yeah, the number you got when you divided by 2 is the number that goes in the parentheses. So we've got x minus 1 squared. And then the number we got when we divided by 2 goes in that second set of parentheses. So y plus 2 squared. Negative 4 plus 4 plus 4. 4. Now, are ellipses supposed to equal 4? No, what do they equal? Not 0. They equal 1. So we're going to say divide by 4, divide by 4, divide by 4.
So that's the only thing different about what we just said.
Yeah, so these are going to feel very similar to circles, but when you complete the square with an ellipse, one of them has to have a number other than x squared or y squared. It's going to have some number in the front. Sometimes both of them will have a number in the front, but at least one of them will.
Am I killing the cow or does the first one cancel?
The first one cancels. You did not kill a cow. All right, and then the last one cancels as well. 4 divided by 4 just equals 1. So the equation of the ellipse is x minus 1 squared plus y plus 2 squared over 4 equals 1. So in that example, this form is called general conic form. This form is called the standard form for an ellipse. Okay, and the standard form is beneficial because we know where the center is, we know what the radius is for the left and the right and for up and down, and so we can find all of our specific points and all that from that standard form. We can't find it from the general form. Okay, that's all we're doing. So you're going to take your worksheet, you're going to flip it over to the other side, and that's what you're going to be working on, and that's what you're going to finish for homework. Yes? Yes.